So let's start with a little bit of poll over here. Has anyone heard about ProxySQL before? Okay, there's one person. Okay. Are you anybody's using any proxy solution in their current environment or managing one? Okay, we met with before. There's one over here. Okay, we've had a meetup before on proxies. So this talk is going to be about a proxy solution specifically designed for MySQL and MySQL topologies. And we're going to talk about the use cases of the proxy, and we're going to drill down on a tool called ProxySQL. So what is ProxySQL? ProxySQL is a protocol-aware proxy that is able to communicate between the MySQL database servers and the application server. So you actually have a tool in between the application layer and the database layer. And ProxySQL is not the only solution. There are other proxies in the market, some of them open source, some of them aren't. And using these proxies, you can actually allow more scalability options and some other features that you want to actually put it in front of your database server. And so, of course, I forgot to introduce myself before the ProxySQL. My name is Alkin. I work at Percona as a global operations manager. I run a DBA team, a global DBA team. We have multiple teams, and one of them is mine. I have 9 DBAs. We actually manage databases for our customers. Rene is also here, the product owner. So he's the founder of ProxySQL. He's also a DBA, and he works in Dropbox and does the ProxySQL development. So I also come from an enterprise database world, and I switched to open source about 10 years ago, and I managed large database operations, including eBay and some other companies. I realized the LinkedIn doesn't work in Russia. Put that on purpose so people can actually contact me, but the Twitter works, so you can actually contact me, follow me, or send messages via Twitter. I can actually give you more information about the tools or the challenges that we face. So we're going to go back to ProxySQL. ProxySQL is already in production and used in multiple companies. The problem with this list is some of them are not confirmed, and some of them we do not know who is using it, because it's an open source product. You can basically download and install it, and we don't have much of a record of who uses for what or what scale. So, but just to mention over here, there's very large companies, and some of these companies, while implementing ProxySQL in production, we have been contacted, especially Rene over here, helped the idea how it can be actually helping the database operation. So we actually brought some of that information to the use cases that we're going to talk in detail. So there's other session about data masking in ProxySQL in about 2 hours from now. Rene will present that. And there was, I think it was yesterday, so this was the meetup about the, so we don't undermine the other solutions. There's a MaxScale, there's a MySQL router, and these are all made for database traffic management, and definitely POC. And if it works, it works. If it doesn't, like, you can try something else. The idea over here is to help solve problems. So why do we need to solve problems? Well, first of all, we want to improve database operations. As a DBA, you actually face a lot of problems, and you have limited tools to tackle them. And with ProxySQL, we found out that we can actually improve some of these operations. We're going to talk about those, what we actually solve with this tool. Also, we add this layer to understand and solve problems. So it's actually while improving, so you understand the problems and actually create a layer to shield the database and solve problems. So these are like top problems and eventually add some high availability to database topology. Anyone uses MySQL, you already know there's a there's an option built in for async slaves. You can add multiple slaves and number of slaves. But how do you use them in production is a bit of problematic because they're async. If you read from them, they may be delayed. If you write to them, it's bad. You get punished. There's duplicate data. And if you don't manage the workload, the read and the write workload correctly, you're not taking benefits of hardware, your virtual machines, or the MySQL instances that you have. So with this tool, you can also add some high availability. We're going to drill down on what are the cases that you can do. And so we're going to empower databases with the great tool. This is basically, Rene wrote this tool for himself so he can solve all the problems. Okay, on the highlights side, I'm going to go through the highlights before we go through the use cases in each of these highlights. So I divided those up into 4 sections: scalability, high availability, query support, and management tool. So unfortunately, I don't have any hands-on time for this, but we can show you how it works in the command line. There are some, we have some friends who actually explored this in production and built some virtual boxes, virtual machines. I can provide you some GitHub links that you can basically download that and package it and just start playing with the ProxySQL in 10 minutes. So it's so on the scalability side, what do we gain using ProxySQL? Basically doing connection pooling and multiplexing. So if anyone has a high traffic in the connection side, you need to actually pool that connections, whether in the application side or somewhere else. And then the connection thread overhead is huge in the database if you hit hard. The biggest thing is read-write split. I just mentioned, MySQL topology has this option for scaling out, pointing reads and writes. Since this tool can actually understand and talk in MySQL in the same protocol, you can actually divert traffic on a read-write. I will show you how to do that. And read-write sharding is another idea that came up, and there's a lot of sharding implementation we've seen as in the market. The sharding is basically done to distribute the workload equally. But what happens is once you distribute the workload, they hit some point. They hit a threshold if that shard is too big, and it's oftentimes we face that. It's very difficult to change the sharding points later on, but if you have something like this in between the application and the database pool, you can basically implement sharding much easier. Again, we'll talk about that idea in a bit. For the high availability side, so what we can do is a seamless failover. So it can actually allow you to do a graceful failover. And again, another common thing in MySQL topology is the master-slave pairs. N number of masters can have a number of slaves, and if the master goes bad or something happens to that, you actually fail over. Also, we do failing over for database operations if you want to change configuration, if you want to change a host, if you want to change some schema or table index, and then we do a failover, took that, put it in a maintenance, and then put it back on. This is like we do that all the time. And doing the failover with other failover managers, if you have something like this, you have actually much better to know which are the master, the promoted. We'll talk about that. The load balancing, again, the read-write split, you can actually do a lot of load balancing, and that allows you to do better utilization of servers, and it is cluster aware. There is PXE, Percona Extra DB clustering solution that actually has the Galera libraries. There's now group replication in MySQL. So you can actually use any of those cluster solutions with the we talked about it a little bit yesterday, but if you haven't heard, there's a script that actually can be triggered by, and then to know which nodes are actually donor or writer. We'll talk about that also. So these are some of the options in the high availability side. Okay, for the query side, so we mentioned that the proxy is protocol aware, so it knows the MySQL protocol. Your database server communicating with the application server is doing the SQL, right? So the SQL actually comes and then pointed to. If you actually intercept those queries, you could do a bunch of stuff. So some of them are listed over here. For example, query caching. You can cache within the ProxySQL. And oftentimes there is a different caching solutions. You could do it in the application side. You could do it in the cache servers. Database has its own cache, the buffer pool, and but none of those are actually granularly modifiable. You can't really. It does its own logic. In here, we can actually say, okay, cache these only. And on the rewrite side, you can also rewrite that query. Why do we have to rewrite a query that is coming to the database? I'll show you why. There's a lot of cases for that. We spoke about that, and it's actually was a good idea. And Oracle also implemented on 5.7 the query rewrite plugin. So it took many years to come to MySQL, but it is there. Unlike this one, but there is something like that. And a query blocking, it's like a firewall in a database world. So how do you firewall your database environment with ProxySQL? You can basically block connections, modify connections, allow connections without any application support to pass through or just be blocked. So in the past, we used to have a lot of access to the database, but lately there's a lot of problems with the security and the data loss and stuff like that. So if you do want to have more control, the proxy layer is the right place to do that. Okay, we have more query options over here. One of them is the mirroring. So this is also a pretty good idea about doing some analysis on the database side. It's not really intended to mimic, intended to use in production for a database queries, but it's actually can be used for audit, analyzing and reviewing cache warming. There's a lot of issues with the cache warming in MySQL world. If you actually promote a new server, there's basically no cache. The technique that is used to warm up those cache in, like bring the most used data to buffer pool, so when the application points to that, is very problematic. It takes time, and maybe some people write scripts for that. I've seen people running a loop and doing select star from those tables, and everybody faced this problem. If you actually promote a new server and put it in production, everything's going to be very slow. And but if you have this option and just put the server behind the ProxySQL and start mirroring to there until you're ready, it can be warmed up, and then you could do the failover or the switch in a split second. There will be no loss. So that's a good idea. The other thing is like, okay, you have a new host. You want to have a baseline of your existing servers, collect some data, look at the graphs, and then compare them. It's pretty easy. So query throttling is another one that actually, since the query is coming in, we can actually identify those queries and say, okay, I want these queries to go first rather than these. We face a lot of problem with the OLTP versus OLAP queries. It's very difficult to distinguish them, and whatever you do, some large query comes into the production database, and it's hard to actually stop that. You can set some priorities. You can do that on the fly. The good thing is, once you have this, if you identify, you can say, okay, these queries can be stopped. And also add another timeout. You know, application can have a timeout. There's a network timeout. MySQL has its own bunch of timeouts. It'll time out based on network, timeout based on, but query-based timeout is actually pretty good because, like I said, I see a lot of companies use regularly scheduled jobs, and those jobs are actually running in, you know, overnight or something. All of a sudden, there's some backup. You know, it has a problem with the backup. It gets stuck. We find out, okay, and then should we kill that or should we not kill that? You know, there's okay. You can set those type of queries in timeout. Let them time out automatically. This is the fourth on the first chart, the manageability side. So the proxy SQL is not actually just basically daemon or just you run in a command line and it just disappears in the background, do its own thing. It has its own admin utility. Basically, you connect just like you connect to a database server, and you have username, password, and the port number, and you are inside that utility, and it's a command line utility, but it's actually pretty robust. So it does support runtime configuration. So all the configuration you have, you can save it to the disk. You can change things on the fly and then flush it and load disk, load in the memory, and that allows on-the-fly modifications to the administration of the tool. The other one is the monitoring. So everything that passes through the proxy layer is collected into its own repository. So the data that you have, you can actually query, analyze, and make some decisions based on that. So this is like, this helps. What we usually do is we go to the backend database server, start searching around. But when that database backend topology is very complex, as some of our customers have, you know, and number of clusters of each master-slave pair, it is very difficult to identify. If you have that data in somewhere else outside of the database, first of all, I feel much comfortable not touching the production database, trying to investigate something and screw up something in there, but do it outside of it. This would be actually a good place to collect those stats and investigate the workload. Okay, so if we actually drill down on the scalability side for connection pooling, this is the first feature used in production. So basically, there's a bunch of ideas that we went through, but this is the actual first issue. Why? Because the network round trip and opening a connection and closing connection is problematic in most heavy load environments, especially for like not if it's not a persistent connection. So if you're actually every database request is coming for a new connection, there's a big overhead. If you rather than if you have that connection already. So so this is like the PHP application. It could be other application. It could be actually a script that is actually trying to connect to the database. Every time you make a connection, and maybe some of you don't see that, but if the things get bigger and bigger and it's more, and then it actually slows down. So so you actually take off that layer, put ProxySQL in between, have application connect to ProxySQL, and ProxySQL connect to MySQL. So it will actually drastically reduce the new connections. It'll have the layer for the pooling, and it will not actually open and close connections to the round trip for the MySQL server. That is under normal conditions and without the SSL. So if you add on SSL on top of that with the additional overhead, it will be actually even more complicated. So made some tests, and the connection time actually reduced a lot. Especially the SSL turns out to be big problem. There's some requirement, you know, if you're doing maybe not in the same data center, but doing cross data centers, and you want to go public internet, you want to encrypt everything, and this becomes a big problem. So I think this was Manjot's blog post. No? Okay, this is So there's a blog post about improving. So Percona, if you haven't heard, there's a huge blog going on, and each of those blog posts are actual real life stories. Usually they're actually tested in production and POC'd, usually went into use, and then we take those and put it in a blog post. So actually it's more educational, and interestingly, you know, a lot of us also use that information because there's more realistic than just talking about the theories. Okay, so the other thing that we're going to talk over here is the same thing with the connection pooling is so if you have, let's say, we said that the PHP doesn't have the connection pooling. I think there is, but not really very popular. But the Java applications have. If you have like a 5 Java, you know, application or framework working in the backend database, opening a connection, that's also a huge overhead. So then actually is the problem is actually made worse, because in case that MySQL server becomes slowed down and those connection pool times out, it'll gonna open another one. So if it's like a 20 connections per application server, it's gonna be like 60 in 3 of them. If it's more than that, usually in, you know, if it's a web-based application, I mean, I managed web-based applications. It could be hundreds of web servers, and that will be really problematic to open a new connection in the database server. Plus, what you actually write is, you know, this illustration is a little bit weak, but normally there's like a cluster behind it. And if you don't have that in between, there's not much you can do. Just everything will go straight to MySQL. In some applications over here, there's the memcache or a cache server, and then it goes to MySQL. And there's also an overhead for invalidating that cache. So, you know, talking about some of the Java applications we saw, the ORM actually brings with lots of interesting stuff to the database. Like, it doesn't care about databases, and all of these that is coming from the application, we see these in the slow log. Actually, we've seen this a lot in when we analyze the queries, and it may be like it may just sound like, okay, how much of a, you know, CPU cycle or a network or database cycle of this? It's a lot when it's executed in millions times. You know, so on the scaling side, you can think there's not much for the, you know, some small applications, but web-based applications, or, you know, depending on busy seasons, peak times, you might have actually all of these. If you haven't seen these in ORM, you're not catching them because they are there. There's a way to disable them in some of the ORM applications in the configuration. Restart the framework and then it'll go away. Or you can use ProxySQL in between. This is another actual use case that Life 360 actually was having this whole problem, and once that is installed with the ProxySQL, everything that they didn't use any of the special features, anything very complex, and basically pass through that that connection layer to ProxySQL, and the result was amazingly different than what it was before. Okay, we continue on the scalability side. I already mentioned the read-write split. So how does the ProxySQL do read-write split? This is not very what new feature, so it's been there for a while. And also this, like I mentioned, there's other proxies that can do that. One of them is HA proxy. HA proxy is able to do this, something in similar using multiple ports. You still need to write or manage the HA configuration. There is a way to do that with MHA, or, you know, other tools are there. But with the ProxySQL, you can actually do on-the-fly read-write implementation. There's the master, there's the slaves. You add the masters that you want to have in the right host groups, create a new host group, and then put the read slaves, all the candidate read slaves, and basically do the read-write splitting within the ProxySQL. And so if you put that inside the proxy, when ProxySQL uses the read-only flag, so MySQL has this flag enabled or disabled, 1 or 0. If it's read-only, it should be read-only, and no traffic goes no write traffic goes through ProxySQL to a server that is marked as read-only. And this way you can actually load balance things, and it's easy to implement with other configuration managers. The ProxySQL will constantly monitor the flag within its own daemon, all these hosts that are actually attached in the configuration. And if there's a change in the configuration, for example, if one of them is crashed or promoted as a master, it won't send the write traffic to the wrong hosts. Okay, we spoke about sharding a little bit. So sharding is a not very basic thing. So, but the idea over here is, can I shard per username or per schema to distribute the workload differently than the traditional sharding? Because the traditional sharding, you have to actually split your workload based on the hardware and based on some criteria that, you know, it could be customer ID, or it could be date time. And in this case, you can actually create a sharding scheme within the ProxySQL and say that the traffic can go to these hosts depending on the criteria. So you can actually parallelize queries, and basically the idea over here is to go beyond the sharding per host limit, because if it's the traditional sharding, you're like limited to that. Everything goes to that shard, regardless of that shard is able to serve that traffic. Here we can basically set some standards on our username or schema and do that. There is another blog post over here. This was probably written by Marco, and actually has the POC, explains that how this can be implemented and how can it benefit. So he created a nice use case scenario for illustrating the details of the sharding. So I recommend going and looking into that. So there is, I think there will be a new version of that also. He was blogging about, but this was the one I actually looked up recently. Okay, so on the high availability side, what do we have for the failover? So we mentioned about the read-only flag. So it has the knowledge of which servers are read, which servers are available for master, and if something goes wrong with the master, it can actually, you know, take over that master, and it knows that that flag is changed. So you can actually integrate with other HA managers, like I mentioned before, and this is a pretty also standard operation. There are, if you're not familiar with MySQL topologies, there are HA solution managers for the MySQL master slave pairs. So one of them is MHA, very popular one. The other one is an orchestrator. Both of them are used. You can integrate ProxySQL with them. HA manager does the job for promoting new server to a master, and ProxySQL knows which server became master. You don't have to do anything on the application side. That's the whole idea, because oftentimes what we have is something goes wrong with the database server, the whole operation becomes application related. Application needs to know, they need to restart the application, they need to, you know, it becomes a huge problem for us also. I'm talking from my side of things, because we manage databases for our customers, and the customers are responsible for the application. If I could do everything on my side, they don't have to do anything, it's perfect. But oftentimes you have this change happening in the database server, because it could be anything, some sort of issue with the disks. I mean, we face a lot of problems that, like the battery goes bad on the server. Data center has some network outage. The master becomes like iffy, and then things get complicated. So okay. So this is another use case. So this was an actual use case also. It was done in production, and this was done in Tumblr. So they actually had to migrate their data center to another data center. How do you migrate your data from one data center to the other one without having a big outage? Well, they decided to do it with ProxySQL, and basically the application was seamless to the application, and they added ProxySQL in between, and then started pointing the traffic to the other data center. Okay, you're gonna ask me, why can't I do that with my application to point to the other data center and then start migrating my data over there while the application still goes on? Well, there was a huge delay. It was even bigger delay if you actually went across data center outside of the local data center, because this application server was not in that data center. Until you migrate everything over there, you won't be able to do that. In order to switch over, you need to actually migrate the data. So they actually chose to do this to avoid delay in the queries, because the queries would, if they pointed out initially to the second data center, that they were delayed and it was timing out the whole 9 years. So it was a problematic implementation. But with ProxySQL, they were able to solve that problem. This is the one that's actually SSL connection thing. So on the high availability side, we have the clustering solutions. Okay, I mentioned about Percona XtraDB, Galera, and a group replication. So all of these do multi-node implementation. So this is like so-called master type of design, but usually it's like only one node that you write and read from the others. And we've seen implementations, a cluster, there are 3 nodes, and there's another slave for backups, there's another slave for delayed slaves. So it's very common in clustering world. Lots of gaming companies use it that way, because the games can be in that topology itself, and online games are like, so that way it doesn't actually impact the others if there's something to all the games. So I mean, in my experience, I've seen a lot of gaming companies do that. And so with the ProxySQL in between, you can adopt that. Why do I need to adopt ProxySQL in this kind of scenario? Is because if something happens one of those nodes, you want to make sure that application is actually pointing to the right server. And this is done by a script. Normally, when you send that traffic to the right node, it's okay, but if things change, you need to make a modification in different layer. And with ProxySQL, you don't have to do that. You define that and then run that script. Script runs like a scheduler, and then it points to the right server in the backend. Okay, the caching layer. So we actually have this in the ProxySQL for caching stuff, and this will actually help. So there's a cache in application mentioned. There's a cache in the database server. Adding a cache. Why do we need to add a cache in between? Is because we can actually granularly set what we want to cache exactly, not everything. So improved over query cache. MySQL's query cache has not been very good. It's been problematic, and we've been recommending to disable it, all of it, all together. Up until recently, it's been used in MySQL, but in version 8, if I'm not mistaken, it will be deprecated. So even Oracle doesn't think it was a good idea to have query cache within the database engine. So it's gonna go away. We tell to disable it, don't use it because it's really not efficient. But if you really need to cache something, you can do it in ProxySQL. So this way we can actually, again, avoid any changes to the application layer. Oh, one more thing over here. How does the caching work? This is not really super complex. There's a time to expire, so you can actually set, okay, this query can be cached for, this data set can be cached for like a minute or something, and you can set some barriers to not to actually serve stale data. Okay. The timeouts. I mentioned there's a timeout setting, and there's a Percona toolkit has a kill script that you can actually set to kill certain queries if they exceed the time. So we call that a query sniper, and it's basically is a killer. So again, in your production environment, you see oftentimes there's this, oh, this query is taking a long time, it's making an IO high, network crappy, and what do? Just kill that server. Sometimes killing that query that is like running for a long time is also problematic, as it's the buffer pool issues. There's lots of internal issues with the long-running queries that is not needed. So if you can identify some of those queries coming in beforehand, you can basically get them timeout and be killed, not even sent to database server at all. So this is to create clean database connection. So by installing ProxySQL in between, you already actually have a long way to go. At some of these features, then you'll have basically no idle connections, or the long-running process in the backend may actually save a lot of resources to begin with. The application, you know, I'm sure there's much more experienced application people over here. You have development pushing code, things change. We can't change things in the backend until it happens. So everything goes okay, and then one morning you say, okay, there's something wrong with this server. It's either slave being delayed, and it's like, you know, there's latency increasing. By the time you find out, it's kind of late. You want to do that before. Okay, the firewall is actually, there's no really a firewall in MySQL databases. There's much more user authentication and you know, features to manage MySQL access in the recent versions of MySQL. But if you're in older versions or using plain vanilla setup, there's no really thing. So we've had this problem a lot in the past. I don't know if it still happens. Databases used to be much more exposed to the outside world and would have a huge traffic spikes. It can still happen. We've seen that on special days like Christmas morning. On some customers, you know, everybody starts opening there, and then they decide to register, and then all that traffic comes in the database, and there's not much you can do. And so on that behavior side, if you have a ProxySQL, you can block some of the queries or block some of the access and give more granular access. Query rewrite engine. Okay, this is something we need to talk, because this is an interesting feature that Rene and I spoke, and he always wanted to make changes because he wants to fix the problems. Um, how do you rewrite a bad query? The query chooses a wrong plan. There's no index. There's not optimized for or tuned, and application is not going to change. When you ask the development, can you change this query? It may take 3 weeks. You don't know. So basically, whatever query is coming, force index, use a better SQL, optimized SQL. You could do that in ProxySQL. So this is was the most wanted feature for DBAs and Rene. So he could be able to actually rewrite the query that's coming in on the fly without having to ask development. Once the development fixes the problem, it fixes. And in MySQL, if you're familiar, changing data structure is also problematic. There's a popular tool by Percona called PTOSC, online schema change. Without locking the database, you can change it, but it may take time. So, for example, if you want to add an index or modify an existing index, your database operation will take time until you fix that problem. If I can actually do a query rewrite within the ProxySQL, then you can do that in the background. Once it's done, you can just disable it, and it'll be perfect. Okay. How are we doing with the time? Okay. Couple minutes. Okay. I think query rewrite is the one that we mentioned. Query mirroring, I wanted to mention about this, especially for cache forming. I would use it for benchmarking a lot. If I have a tool like this, oftentimes we don't know the new host, what's going to happen, how it's going to behave, or there's a disk unit both on something like that, or new server provisioned, and you could actually basically use the query mirroring option to point traffic to two places. This is not actually a new invention or reinventing the wheel. The old firewalls, the network firewalls, had this feature for analytics actually. So I used to work with security departments, so they would analyze the incoming traffic from the net, and they would actually install a firewall, network firewall, would mirror that traffic, and you would actually be able to immediately analyze that data on the fly, as opposed to on that host. Another one quick recent development over here, the ClickHouse column store. Since it doesn't know the MySQL protocol, there is a library written by Art, and the application server that connects to regular database MySQL backend can connect to ClickHouse. If it works for your application or implementation, ClickHouse is pretty cool. I would say check it out. And with the ProxySQL, you can actually do that. There's a link, didn't show up over here, but if you ping me, I can send you the GitHub link for the ClickHouse implementation. I'm not very familiar with the ClickHouse, but this was like, again, since it's a use case and it can be used, you can try. So the clustered, it's basically a multi-layered ProxySQL tested with these layers, so it's layer over layer. When things get really complicated and big, you can basically have multiple ProxySQL layers, and be able to do that, reached huge numbers. So while we say, okay, you can scale your databases, you can also scale ProxySQL, because ProxySQL will have benefits if you layer them. So 8 app servers, and then there's 4. Each app server has a ProxySQL, and then there's a 4 middle ProxySQL. It actually can go. So there's other numbers over here that was all tested. The numbers in the website. To wrap it up, these were the options on the query side that you can explore, and that's it. And thank you very much for listening. Do you have any questions?
First of all, many thanks for great introduction and ProxySQL. Just a little question about connection pooling. You said that we have a big overhead when we wrap every query in a connection, in a single connection when we query the database. And ProxySQL can tackle that problem. And it is not clear for me how it can be with the ProxySQL, because anyway we need to establish connection with the ProxySQL, and we need do it every time we query the database. So how it can tackle the problem?
So basically, ProxySQL will open a connection to the database. It's persistent connection. Your database server connection is done. Your application will connect to ProxySQL. All that overhead is filtered in the ProxySQL, and it has optimized to perform much better than regular MySQL backend.
So that means that latency latency connection with the application with the ProxySQL much fewer in compare with the connection application.
One thing we didn't mention is putting ProxySQL in the application server is ideal for this kind of scenario. So you actually put the ProxySQL in the application server, and then ProxySQL will connect to the database server. So your connection is local to the ProxySQL, and ProxySQL connects to the database, and it's already connected. You're only opening a connection locally, which is super fast.
Okay, thanks a lot.
Any other questions?
Okay, hello, thank you. I have a small question from my colleague. Sometimes we don't want to split all write and select queries. For example, when we write something in master and we want to select from the master too, can we do it from ProxySQL, or we need to put this in our application?
Yeah, it would be good to. Yes, there's an extra microphone over here. Is this working? Test. Yeah, this works. So.
Okay. So when you set up read-write split, the principle is that you don't send all the select to the slave. You from the proxy, when you execute queries, the proxy is collecting all the metrics. So what is my recommendation is start sending everything to the master. And then, because the proxy collects metric of all the query, you can easily identify which are the query that are okay to be sent to the slave. And then you can instruct the proxy that from that moment on, every time it sees that specific type of query, that query has to go to the slave. And it uses regular expression. So you can say, for example, all the query against table X, or all the queries that have group by, and so on. So you can actually specify which query has to go to the slave. That's one approach. The other approach is that if you want that a select following a specific query has to go to the master, you can create a rule that says every time that the write happen, one specific write happen, the next query has to be executed in the same connection. Doesn't matter which is the query.
Thank you.
Okay. Sure, keep it. More
thank you
questions.
for your presentation. I have a question. I have Galera multi-master cluster, and my application is requires static auto-increment in database. If I'll write in random server with Galera, there is a chance that I'll have auto-increment changed in the process of Galera syncing. You offer to place ProxySQL at the application server, and I have 10 servers. So is there a way to sync who will be the master of the masters, which we using read-write split, so that I will write only one server for all the 10 application servers and read from others of the multi-master cluster. Is there a way to do it?
I'll let
So
Renee answer
with
that question.
for Galera, there is you can configure all the proxy with a scheduler that is basically a script or an application that the proxy can execute, and you can use this script to constantly check the status of the clusters and elect a master. So you will have only one writer. So it will happen that all the proxy will constantly check the status of the server and choose which one is the master. You can create some criteria, like for example, the one that has the lowest IP and it is not in the sync. So you will have that all the proxy will always write to the same master.
Is there a way to make it automatical, or I need to reconfigure in the files of ProxySQL?
The scheduler is basically a cron-like cron-like algorithm. So the proxy itself will execute the script. So this script, what it can do is it check the servers and then it connect to ProxySQL itself and reconfigure it. Because ProxySQL you can reconfigure it at runtime.
Okay,
So that's very easy.
thank you.
So you're not writing all the nodes at the same time, right? Is it just one
Yeah.
node? Are you writing all of them at the same time?
I need to write only one node,
One node,
and
yes.
read from others.
Okay.
So in case if something happens with the main server,
I think you can do. So if you download the Percona Extra DB 5.7 package, this script comes along with that. It's packaged inside, so you can try and see if it fits.
Okay, thank you.
So the ProxySQL is also packaged in that.
There is a question there.
Yep.
Hi, great talk by the way. One quick question about the query replication. First, I have a query that is sent to the primary MySQL server, right? And then I decide to replicate it to another cluster just for, let's say, testing purposes. I'd like to ask, are those two made in two separate threads inside ProxySQL? Because I'm wondering what will happen if, for example, the query that goes to the test cluster stuck somewhere, for example.
Okay. So in proxy, all the traffic is handled by a fixed number of threads that is configurable. By default is 4. So this means that even if you have 100,000 client connection, there will be only 4 threads processing them. So those 4 threads, they can handle a huge number of connection. And all the operation is async. So it doesn't block. So the real traffic, in the case of mirroring, what's happening is that the real traffic is sent to the real backend. At the same time, ProxySQL create an internal session, and this internal session does nothing more than send the query to another backend, the mirror one. It's not a different thread, it's the same thread that take care of this, but just a different session. And because all the communication is async, the real traffic is not blocked by the mirror traffic.
And it only returns from the real one.
Correct.
There's no,
Yeah.
it's like a black hole. You're sending that
Yeah, it
query.
just copies to the
Yes,
place,
but you don't
to the-
actually bring the wrong or test data to the.
Yeah,
to the
I was
original
wondering,
requester.
as long as it's not blocking for the
It's not blocking, but also it's not returning any on the mirroring side. It's for testing purpose. So it's just like a dummy.
So
request.
it doesn't create any sort of overhead, so the real traffic is not affected. The only exception is if you're sending too much traffic to the proxy and you are saturating CPU utilization, then of course the proxy start struggling because it has to serve twice the traffic. So CPU utilization grows.
Hello, thank you for the presentation. And you showed already the blog of Percona, and my question is where I can find like good configurations for the ProxySQL, like examples.
I think the GitHub wiki page had some examples.
I think it is something that can be improved.
Thank you.
See, it is it depends on what you want to do. It's difficult to come up with like a configuration in hand. But if you have some ideas, you can just.
No, I'm just want to use ProxySQL, and
Sure.
like I just need more information about the cases you
Sure.
mentioned in the
So
presentation.
in some of the blog posts have the basic configuration for that type of solution. You can take that one, start testing, One we mentioned is to collect the data, and there's the statistics, and make a decision based on that. It's better to have a baseline. So without having that information, it's difficult to say something.
Okay, thank you.
Unfortunately, time is up.
Time is up. Okay.
So you can
talk
ask
later.
some questions for our speakers
Yes.
out of audience.
Thanks.
Thank you.